Recording in progress. How are you? Wait. Let me see if I can improve. Hey, now, can you hear me? Okay. Roberto, how are you? Can you hear me?
Trying to manage a lot of it.
So many things. Yeah, we never stop here.
Yeah.
But yeah, we like to offer you the, let's say, everything that it happens on the house, let's say. But honestly, if you cannot attend all of the classes or whatever, we try to record, and I know it's not the same, but at least
Yeah.
you don't miss anything.
I try to obligatory attend global, try to fill as much as I can, and try to also be on Wednesday morning when you have an introduction to the topic, and also whatever it's great. Yeah, I am aware it's not possible to have a similar situation as I will be there, but yeah, it's more information. It's even better, and particularly this topic of precious plastic is something interesting also for my colleagues here, because we have actually in waiting for clearance of the contract related to precious plastic recycling. So I'm curious to see and to hear from you what you are doing.
Okay. Yeah. Okay. So for this week, also for you, Roberto and Mayra. Mayra, I don't know if you have access to some tools, but on Wednesday, okay, especially on Wednesday, we will do again this station idea, less crazy than last week. So there will be just 3 stations. I'm saying this because if you're gonna try to prepare in advance and just try things on the same time, it's okay. And we will go through basically how to milling with the SRN20s and the new ones that Niels I suggest, the Chinese ones, let's say. So from mods to milling, okay? So this will be one station. The other station will be how to solder and how to debug that solder. And the third station will be basics concept of electronics. Okay, so let's say the idea of a circuit and also basic components, and probably we will do it with the boards that we already milled. So what I already tell Edu to send you the design of the boards if you want to replicate it, okay, in advance. Let's see if we can improve the experience this week a little bit better. And that's it. So here I'm waiting for everybody.
Okay.
Hello, Sandok. Hello. Well, this is kind of everybody, okay, for now. And that's it. Mayra, ¿cómo estamos?
Súper. Estoy desde las 4 despierta. Ya me acostumbré al horario ya.
I will try also to connect.
Creo que se fue. I think Santi is out.
Yeah.
Oh. Ahí está.
Faber Cannon.
Where are you from, Roberto?
From Croatia. Croatia. Yeah.
Okay.
From Zagreb. From Pavlov in Zagreb.
Okay, Zagreb. La capital. Lima, Perú.
Oh, in Peru. Okay.
Yes. Santi, no te escuchamos. We cannot hear you. Oh, creo que tiene problemas. He has problems. with the connection.
I want to connect with my mobile because I want to show him machines we got here also. So
you are at the lab.
Yeah, I'm in the lab right now. Yeah.
Sí, te escuchamos.
Very important people in the Fab Lab network. You know, there's attention. No, you're like you're sharing. You're sharing? Yes. Yeah, perhaps sharing. So we are recording. So remember that with the
His connection is really bad. Hi, Santi.
Bien, si lo teníamos grabado para el próximo día no tener que repetir.
Claro. Hola. Hello. Thank you. Can someone speak?
Yeah. Hello. Good morning.
Hello.
Okay. Just say something to make sure they hear you.
Can you hear me?
Yeah. Do you hear like clearly when we talk?
Yes, I can hear some voices far away.
I mean, this has a microphone, they told me. So. No. Okay. Let us know if you can hear. Okay.
We can hear you.
Okay.
Yes.
Because you can hear me.
What? Muting.
It's not in the audio connection, the settings.
Sorry, guys, we have an issue with the headphones.
Do you hear?
Now, can you speak, someone?
Yeah. Hi, hello, morning.
Okay.
Like,
Thank you. Thank you.
it's like it means perspective, like I'm not sure whether we can
Yeah, you should come if you want to, but no pasa nada. Yeah. Daphne? Works? Huh? Not touching. Okay. Hello, everyone. Hello, hello, hello. So if you mind and gather as much as COVID friendly it can be, I guess not at all, but that's fine. Welcome everyone to today's session from Make Material Club, whatever. I'm really happy to have you all here and to share this moment with you. I'm Jess. I work for FabLab Barcelona as a researcher, and today with me here is Mickey. You know him. Arman, Daphne, you also know, kind of. And we're going to talk today about precious plastic in particular. The session is divided in 3 main sections. In the beginning, we're going to do a little introduction of precious plastic, what the material plastic actually is, and then go into like hands-on activities, mostly, thank you, mostly with Mickey and Arman, and also some low-tech stuff with me. And then in the end, we're going to have 20 minutes of just short reflection and key takeaways from that session today. So before we start, and before I'm going to start talking about stuff, are there any big questions from you guys which you already have and bring to this session where you have like, oh, I really want to know this, that, and that, so I can integrate this in the first 20 minutes where I'm talking? Or otherwise, I just, yes.
Is there a way to make a mold if you wanted to compress? Will you go over that? Or this is the only mold that you have?
We will go on that later, but that's a good question. Anything else from you guys?
Could we have your names and backgrounds?
Yes, sure. So my name, Jess, as I said before, I did MDF the first iteration 2 years ago. I'm an industrial designer, but now work as a researcher for circular practices, circular communities, and these kind of things, and different EU projects here in-house. Mickey, name and background?
And my background is about graphic design and programming for games. Yeah, we're here. I'm kind of like in this kind of topic, I'm kind of like setting up machines and trying to bring to a next level the machine before. So that's kind of my role.
Arman?
Arman?
Years ago here, and I did Fab Academy, like finished Fab Academy last cycle, and I've been working on precious plastic almost for 3 months, almost. Yeah, super close.
So, first of all, we're going to talk about plastic, the material itself, right? Plastic comes in very different forms, as you may know. It is extracted actually as a like original form from oil. But what the issue is, what we have today with plastic is that it's used for tons of applications. Sorry, it's Monday morning, so it takes me a while to get into the mood. But the life cycle of it is often not considered when we're using plastics. So there are 2 main categories from plastics, which we're working with, which is thermoset and thermoform. Thermoset, as the name already suggests, is that the plastic is set in its form and cannot be used afterwards in, like, for example, melting methods. A classic product for that would be a bowling bowl, which you use. It is formed as a bowl, and after that, you cannot heat it up to recycle it again. So we do not even touch the topic of thermoset plastics, really. The other one is thermoform plastics. So these plastics we can recycle in the sense that we can, through heat and pressure, we can reuse it. Or also there's other material, like for example, through shredding there. So in the category of thermoform plastics, there are multiple other plastics. Generally, plastics are a chain of molecules, polymers, and then there are multiple applications for these kind of plastics, right? So you can see already some examples here. We have all different kinds of plastics that come in different colors and different materialities. And the key aspect before we actually start working with plastics is to being able to identify them, right? So if anyone wants to come and just by looking at it could tell me what kind of plastics we have here. Is that all the same? Are there different ones? Is anyone feeling like telling me this? That's first thing, right? There are different kinds of plastics here. If not, I'm just gonna go ahead. PET, thank you very much. So this is a PET bottle. I think all of you know this. You can hear it, it's really crunchy. And we also have an HDPE bottle, which is this one. Makes very different sound. I also have this, which looks similar to PET, but it's actually a different kind of plastic. But when you just look at it, you couldn't be able to identify this actually. So how can we identify plastics? The first and most easiest thing is to look for the resin code. The resin code, I think most of you probably know, it's a little triangle with little arrows, and it says 1, 2, 3, 4, 5, 6, 7. 1, for example, would be PET. Then 2 would be HDPE, high density polyethylene. And so on and so forth. PP would be polypropylene. But there are actually other ways also to identify plastics. And one of them I already mentioned before. So we have PET. And you can hear by the sound, it makes a specific kind of sound. Also, most of the time, PET is see-through. But then if you go to high density polyethylene, it makes a different kind of sound. And if you have, but then the issue with the visual identification of plastics is that you can apply or make through the form or the thickness of the material itself, you can kind of fake a different kind of property. And that is what makes it a little bit more difficult. Because here we have HDPE. It's soft, it's opaque, we see it in the bottles, but then we also have HDPE here, and it's hard. It's not flexible at all. So that's what makes it a little bit more difficult. So besides the visual and the resin code, there are also other ways to identify the plastic. One other way is, for example, to burn it, which I do not recommend at all, because it releases toxic fumes. But you can basically use a piece of plastic, styrofoam, whatever you find, and burn it, and you will see by the flame if it's you see by the color of the flame, as well as if it burns long or stops burning immediately, if it's melting, what kind of plastic that is. And these kind of things you can look up, because also, like, I'm not a huge expert on every type of identification for plastic, but these are like the general rules. No? And there's another test which we can use if you already have shredded plastic, for example, is the density test. And I like this one a lot because it makes really clear the density of the type of plastic we have. So, for example, we have here from our 3D printer lab tons of plastic, but it's all mixed. So now it would be hard. Well, if you're Mickey and you know what kind of plastics we use in the lab, you probably know which kind of plastics are in here. But if you're not, it would be hard for you now to identify what is actually in here, what kind of plastic. So there's one way of doing this, for example, is you can add into water. I'm gonna use this. And you will see that some of the plastics will float and some other ones will fall down, which means the density of that type of plastic is different. But the problem with this is that you can only identify two different kinds, right? Because there's the one that is floating and the one that is on the bottom. And it means it's a long process about gradually changing the density of the water, which, for example, you could do with salt. You can just add the salt in here. I'm just going to add tons of it now. Let's see. And it will change the density of the water. And you see now more things are falling down in comparison to before. I will add just some more of this here. That there's way more here on the top than before. Also, another issue we have with this one, besides that you can only do 2 at a time, is that the plastic is afterwards wet. So it will take, and it's already shredded, so it's kind of like difficult to sort it again. So what this says is that in the process of recycling plastics, it's important before we actually start recycling it, that we sort it and organize it. So how we do this, for example, here in the lab, or at least we try for now, like we're still in the process of doing this, is setting up different stations where we try to identify what plastic streams we already have in the lab. For example, from our maintenance team, we have a lot of cleaning materials. And then because we have a 3D printing lab, we have a lot of 3D scraps, 3D printing scraps. And so these are like identifications, kind of materials we can recycle here, or like we can see sort here. Exactly. So these are the types of identification of plastic. And later on, in the more tangible, physical making activity, we will try to do this ourselves here with some of the plastics we have here, and then try to also make some stuff out of it. So, okay, this already says we have to sort the plastic, which is the key aspect of trying to tackle this issue, because from the plastic materials we're using, only 2% of the plastics we're using and on globally is actually being recycled right now. And that is a huge issue because we're producing more and more and more. But even if we put them into the bins on the street here in Barcelona, which is already like, there's one bin for all the plastics, which is kind of like stupid. It is not that well recycled. For example, for me in Germany, we have 5 or 6 different kinds of plastic recycling bins, which is already a better way of recycling because there's the whole system from the city or from the country is already better in place. But as a citizen, we all can do something about this. No, we can try to use less plastic and we can try to reuse it as much as possible. So having precious plastic in a fab lab is actually a really good idea because we already have the machines to reuse them. We have a laser cutter, so if we make a material like a sheet, for example, we can make new products out of that. We have waste streams in the lab itself. We can identify these waste streams and can see what makes sense together, maybe with our community here locally, what we can do kind of workshops, activities to share the knowledge about plastics, but also do hands-on activities through which we learn and find new ways of applying recycled plastics. For that, collection points have to be set up. Having a collection point, for example, in a fab lab doesn't make much sense because we literally do not have the space for that, right? You can see it's everything is full already with machines. We have the students here, we have you guys here. So it makes sense to actually, in the city or in your neighborhood, to see what kind of actors are there, right? So you have the fab lab, a space for making. You maybe have another space where they collect the plastic, so we could work together with that collection point. Maybe there's another place like FOSS, it's Espherica, they are making sunglasses. They make products out of plastic. So it's about how we can locally collaborate, not as a single actor to try to solve the issue, because that's way too much as a person, as a lab, but actually collaboratively work on this issue together. So then on a more like practical level, you figured out your network, you learned about how you can sort plastic, identify plastic. The other aspect is that we want to recycle it. So what the hell do I do with this when I have this now? I know now this is HDPE, the code tells it to me, but it still smells like cleaner and there's no way of doing anything with this for me personally right now. So the first step is that we have to clean the plastic always, because if we want to use it, we have to make sure that the plastic, because it is a precious material, is in its most original form as possible, which means you would have to take off the kind of outside, whatever this is, paper with probably also plastic coating, have to try to get off all of the glues to in the end have something like this. Arman beautifully prepared already a couple of these examples, which they don't have any glue leftovers, they don't have any labels, they're all washed. This is the perfect example how we can recycle plastics well. But before we actually recycle them, destroy them in a destructive manner, like for example with the shredder, we can do one step before, which means obviously reducing our plastic usage, but then also thinking, what can I do with this without destroying the material itself? Because for every iteration where we shred, melt, and do a new product out of this, the plastic loses the great characteristics it actually has. Because plastic as such is not a bad material. That's why precious plastic is out there, right? Because they want to spread the knowledge about this is great. It sucks, but it's great at the same time. The property it has is amazing. It's long lasting. we have different kinds of plastic for which are food safe, for example, which are like a topic which is not necessarily the best, but for specific applications, this can be great. No, so if we have this, we can actually think before we shred it, what can we do with it? So I mean, here in the lab, you can already see we try to reuse it also as storage. We have a little storage unit back here where we sort our plastics, which is kind of nice. I mean, it's still not the perfect usage for it, but it's a way of extending the life cycle of the product itself. And then when we maybe find a new usage for it, that would be one way. But then there are other ways of recycling this material. So I think the one that most people are interested in and the one that is most fun is shredding it. Because if you shred it, you have these little particles, you can make beautiful sheets out of it. Like, for example, this one with patterns and colors and whatsoever. But there are also more, I would say, low-tech ways of recycling material, the plastic. One which I like a lot, and I think is very valuable because still until today we are allowed to use plastic bags, which is LLDPE, which is this. It's actually a bag which it's really sad because everyone uses this once, or most of the people use this once. No, it's like you get the bag, you use it, and then you throw it away. Some people even use it maybe twice for putting in their trash or taking out their trash. But actually, this is a really nice material as such, because through very low-tech techniques, we can make a kind of fabric out of it. So these are just two of the sheets I melted together with iron and made a fabric out of it. Well, it's not really a fabric, but it's nice because it keeps the property as a plastic bag has, but it's more stable because it's waterproof. There's no water or something that comes through it. So one example of how to reuse this is make a fabric out of it. And then you can, for example, make a bum bag, which I randomly made. But it's one way of recycling and giving another life to the plastic, the material itself. Then there are other ways, which we often see in African countries, for example, what they use a lot is a bottle cutter. And I really, really love this one because it's kind of a pain in the ass, I have to say, to use it, at least the one I have. But it's a fairly easily made tool. It's a piece of wood with a razor blade, and you can use it to make strings out of bottles. And they use the strings for weaving. So a lot of times they make chairs or like the structure to sit, or like all different kinds of like little baskets and stuff out of this, which is really nice. Talking about plastic. And there are also other applications for the recycled material. And I think that one nice thing that Mickey has been working on is making some molds. So we have some examples like this. This is injection molded from plastic pellets, as well as this one. It's a little carabiner. So these are like nice little products. But when we make products out of recycled plastic, it really makes sense to think what kind of product we make. No, because we don't want to recycle the plastic just to make another bottle, because then what then? It's going to go the same life cycle again. Someone is going to shred it and it's going to use it for whatever again. So when we make a product out of recycled plastic, it makes sense to rethink as a team or as a personal, like an individual, what the applications of this could be. So one really nice example from Precious Plastic, me personally thinks that at least, is that they make switch covers. It's a really simple product, which we use every day. And they make little switches like this. And it's beautiful because the switches, they're black, white, gray, boring, whatever. But if you imagine a switch having this color, I think it's something beautiful. It can be something beautiful. And it gives really a value to that very simple everyday product we have. And it's something we don't exchange next week. We install these things in our houses and we have them actually for the lifetime of how long we ever live in that house. No? So that's a great application. Another application could be making furniture, for example. And then when we have these sheets, in whichever form they may come, here, for example, we have a thinner one. We can make, for example, if we have a thicker one, a tabletop or whatever. We can also think how to make joints or different forms out of that sheets. This one is a really nice example as well. It's from the Precious Plastic Challenge from 2 years ago, where the Fab Lab worked together with Precious Plastic in Eindhoven with some designers to make new products out of that material. And they made these joints for a table. And they're really, really beautiful. Also, the nice thing is if you have this, for example, and something breaks, I don't know where I put it, that you can easily heat up the surface where it broke and join the pieces together. Obviously, this will not have the same kind of strength, the same kind of strength as before, because here you see we just joined it again, but at least you can repair it, which I think is a really nice aspect to this. So we did the basic identification, which you guys will do later as well. The sorting, really important, the collection. But then there's one huge aspect, and I think this is the one most important aspect of working with recycling plastic, is the safety of it. And we're not just talking about when we use the machines, but actually when we shred and heat up the plastic itself. Thank you, Mickey. So yeah, this is also a really beautiful example. It's a kid's toy. It's a rocking, how do you say that, rocking chair? I don't know. And they bent the sheet, which comes, as you can see here, it's a sheet. They heated it up, made a form and bent it to make this rocking chair for children. And it's, I think, a really nice example how to use it. So going back to the topic of safety. When plastic is heated up, it can release VOCs, which is I don't know how it's exactly the long term for it, but basically it's fumes you can inhale as a person, which are toxic for you. And these, obviously we don't want to have these kind of fumes. So the best way of knowing these things about what kind of fumes can be produced is by looking up on the internet. You can find everything there, obviously, and look for what kind of plastics are most safely to use. For example, HDPE, LDPE, and PP, polypropylene, are plastics which don't produce high amounts of fumes, which means that they're relatively safe to use in a makerspace or Fab Lab. However, PVC, for example, and I think we have one here, this is PVC. If we heat this up, this actually is super, 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 super toxic to inhale. So always check what kind of plastic you're working with before you start melting just random things, because it can be really harmful for you and the people surrounding you. So a nice thing, for example, if we use
I just want to say that PVC is one of the most natural.
Yeah.
It's actually what it is. It's not like a something. It's chlorinic acid. So PVC is polyvinyl chloride, and when it forms, it compares it to toxic gases, which they are chlorinic acid gases. So chlorinic acid is what we see in the movies, that they melt the people. So
they melt the people. Yeah.
So not even static laser or
yeah.
Always with PVC, we have to be really careful when we are like, let's say,
or not work with it at all here in the lab for now, at least, because you need like the proper gas mask with the 2 filters on the side to work with PVC, but it's not recommended in the first place, at least not here in the lab. So what we want to work with more is maybe polypropylene, HDPE, LDPE, and also the nice thing, that really nice examples how you can not even have to heat up the plastic so high to make, for example, sheets where you use relatively high temperatures, but you can use a simple iron, as I mentioned before, with lower temperatures to already make, already create new materials. No, the same is with a company, for example, called Goma. They make the covers for a speaker and I think for a charger, which they use really low temperatures just to mix the plastic as low as they can possibly do to make beautiful marble sheets, or not even sheets, they directly form them. And it's really, really nice example. So yeah, then obviously besides the fumes, which are the biggest topic of safety when using, when recycling plastic, is also the ones that come with using the machines. And I think maybe Mickey, you wanna talk more about the safety with machines and using plastics? You want to?
Yeah, we can get specifically to talk about all the machines, and maybe also we can, so we can have like a history of where we come from and where we're going. Like I can tell a bit of what we had and what we have and what we will have. So, well, I think in the safety we will come, but I just want to introduce the machines. As you see there, we have the so basically, we had like these two machines since like 3 years, I would say, or maybe more, maybe 5. So basically, they were a little unsafe and they were not maybe properly assembled or built. So we had some problems with them. And we decided to invest in them and to change many pieces from them. So basically, as we are in production, so we wanted to have a machine that is pretty safe, or at least like the same design. So before we just had the motor with the switches, one will switch on the motor and another to direct the direction, and that's it. So we have like the weather box, let's say, the coupler and the motor. So basically, like I think on the other model, running a variable of frequencies to execute what is done in order to be able to control one flow related to plastic. So imagine you load that we don't control. At some point, we might affect the metal. If we apply too much pressure, so it will get stuck, and the motor will try to run, to continue running. So then we'll same thing, we can apply the coupler. So the couplers are related to one specific flow. So we blow the plastic flow because we have a lot of plastic that's creating more pressure and more distance. This might flow. The plastic might break and might that this one. Also, we can get a lot of problems before in that this is the place. I got a bit. I don't know what. We don't have any feedback from right? So now it's not that we have a screen and that we see the feedback of our expression in our line, and we basically program this box, to basically not overpass complex. So basically, what we get with this is also to be able to program the motor to say if you have too much load, then go backward for 3 seconds and then go forward again. So basically, it will stop already that there is too much load on it. And it will automate the system, so we don't have to do that in the direction of the line. It will take the time to do that. So basically, it's pretty nice because we can put material, and if we overpass the load, the motor will stop, we will go backward, and we'll try to send the material in another way when we don't get all the time. Apart of this, we also put like so many safeties. So maybe we have an emergency button, so we press this button and the machine will stop completely. So basically, if something will happen, like something will get wrapped or something, we just can quickly hit that and all the machine will stop. So we avoid pulling us inside or whatever, like it can happen. So this is just a safety button. Then we also have here some feedback. There is feedback on like when the machine is on or not. Then we have here an alarm. So basically this will happen if we are putting too much load and the motor feels that it's inverting too many times of direction or something. For safety also, it have a stop. So it will stop, it will pop up the red light, so we will know that something is happening here. Okay. Apart of this, we also added a sensor here. So this is also something that we felt a lot the difference because before we had to deal with a wood or with a plastic here, and basically we had to stop the motor. So if you didn't remember, you open it and the plastic pops out. So basically it's a bit dangerous because it can splash on you, the plastic. So we added this cover with this sensor. So every time we open, we don't have to press anything to stop the machine. It will stop in itself. Then we can add the material, and when we close, it will continue doing the routine. So basically, I think this is also like a pretty nice safety that we added. And I think that's all. It's just like a threading machine, but with all the equipment and safe to make it safe. Then we also have this one. Now we'll go more to work with this one. In terms of safety, there is no safety. So the only thing I have to aware you is that
a lot of heating here. So basically we have to be really aware to be away of the machine. And if we are gonna play near it, to have the equipment for not burning ourselves. So this will get super, super hot. So yeah, just like try to get like as much away we can from it. Things we could add in the future to this machine is also a safety button that it will stop, but as you know, the temperature will take time to raise down also. So basically it's more like a safety that we can take on our side to just be aware with that we are working with heating more than something that we can add onto the machine. So in this machine, we've been trying like in the past, like to do molds with wood and try to do different molds with different materials, which they were not too good to do it, let's say. We took something out, but not super nice. So at some point, we went to what we had to do, which is like to do molds out of aluminum. So we are getting experience into milling aluminum and creating our own molds. For now, we are doing baby steps. We are just yet starting to mold, to mill some aluminum. So we created one mold, like an easy mold, just to test like if we could do the molds here and how far we can go with that. So basically for now we have a basic mold. We will work also into having like nicer molds and things that that we can actually use. No? So we thought to do a clamp because maybe at some point in the lab we can use clamps. So basically, as Jess was saying, we have to think about not doing something one use, like trying to do something that we will use a lot and that actually we will have like long time use. So also in molding, we try to apply this idea into knowing like what we are gonna make as a mold. It should be something that we use for a while and something that might be useful because we will keep taking from one mold like many pieces. No? 3 months ago or something, we started working on like building this sheet press. So basically before what we were doing is to switch on the oven. We have a pizza oven down there. And basically we were having some aluminum baskets or molds, like a square molds. So we were kind of putting there the plastic, putting on the oven, and then taking our board. No? So as you can see, those ones have been done like this. Also here we have Gabriele, which is a student from IAC, now it's working also here with us. And she's been doing her thesis also into like precious plastics. So she's been a lot of time also involved with the machines. That's why she's here today with us, because she's gonna help us to do the hands-on process later. But yeah, basically, I think Arman did that one. But yeah, this is done in the oven. As you can see, it's a bit warped. Let's say like it's not flat, completely flat. Also, the top side is a bit less. It's more rugged. So basically, more round. Sorry. So basically, what we wanted to get with the sheet press is to be able to apply pressure at the same time that we heat a material. So we can take like a nice sheet, flat sheet, as we can see with those ones. That they are flatter. Maybe this is not the best, but yeah, like they are flatter, and this is like easier to, let's say, mill later or to laser cut. So yeah, we built this machine. So basically, we have two bases with heating, and then we have there like the manual hydraulic pump. So by applying here load, we will get them near, and we can apply a lot of pressure into the sheet. No? So we will be working on that. Also, safety on this. There is some safeties. We applied here the emergency end stop. As you see, we are building it. It should be fixed on here. So basically, this is a safety button. Same thing. If something happens, we'll press here. But we have to be aware that this will not take out the load that we have on the machine. This will just cut the temperature, the electricity. So basically, if water falls down or something, we have a short circuit, whatever, like it's sparkling or I don't know. We have this to stop all the electricity on the machine and to start cooling it down. The temperature takes time to cool down, so it's not that suddenly the machine doesn't burn. Again, we have to be aware that we're working with high temperature and that we can burn ourselves with those. Yeah. The same thing I think today we will do with the oven some square molds or some bricks. So again, we will be putting metal into the oven, heating it up. So we should be aware all the time to not touch it and to be protected, let's say. The way we will work to handle the hot materials will be with gloves. We cannot use plastic gloves as we have for the carpentry. We need to use leather gloves, okay? So we don't have so much gloves, but that are the gloves that we have to use. So basically we will keep switching the gloves every time we need to do something with heat. And I think that's it.
Yeah, so in general, when we use the shredder, it's recommended to use the plastic glasses to cover your eyes, just in case there's anything coming out, just to be sure. And the same, whenever there's something with heat, you always use the leather gloves so your hands are protected. In general, you know the rules of the lab, which means safe shoes, hairs are tied, all of these kind of things. It's really important that we keep with these kind of safety rules just to ensure that no one gets hurt ever, as much as possible. So one last thing, when we identified plastic, we sorted it, all of these kind of things, we're making the products out of it. The nice thing about when we shredded the plastic, it takes, for example, less space, because if you see, if you have these kind of big volumes, they take up a lot of space in our recycling bin. So when you shred it, you can nicely sort it. And when we do this, and we will do this together as well today, after we shred some things, it's always super important to mark what is inside. And please never, if you ever do this, if you put a plastic shredded into a container to keep it, always say what kind of plastic is inside. Otherwise, we will have that issue again that we have to identify what is actually in there. And also the good thing about keeping them inside of these kind of containers, which we can close, is that there's no more other materials coming in. We're working in a lab, which means there's dust of metal, of wood, everything, and you can see the dust is like collecting outside of these. The issue we're having with, for example, these open containers, which we're currently still having, is that there's tons of dust on this, which will lower the quality of the plastic, and it will change the temperature from when we actually use this kind of plastic. So keep this in mind when you recycle, when you shred. Always try to afterwards put it into a container, label what is inside. For example, here it says HEPE, really badly labeled, by the way. So it's better to say a nice and big, everyone knows, and afterwards the code as well as what is inside. And then it's easier for everyone else to reuse it and make some stuff out of it. So on this note, I think it would be nice to have about 45 minutes of making things and
before that, someone have any questions?
Yeah.
For
of course.
No?
And you can show what I can do.
Okay, so
If you guys are confused about safety, you can go on the OSHA website and it'll tell you like what kind of gear you need for different materials. So if you want to work with something specific that maybe you guys didn't talk about or anything, you can find all the information on the OSHA website.
Yeah, obviously, with anything, we're not as experts on any topic. We're just working with the materials. So there are always resources online where you can find more ways of identifying plastic, better tips and tricks to recycle, better safety instructions and anything. I mean, that's what we have Google for, right? Because it can basically tell us anything. But this is today is a basic introduction on this topic. And thank you very much for the.
So I would like to say, if we will now get in different groups, so we will split a bit let's say the content that we are saying. If you want to get more information about the materials, about how to take materials, about I don't know, concepts that the people is discussing on recycling materials and on this, you have a super nice website of Precious Plastic where they have a lot of content explaining different kinds of plastic, like different melting points. They share, they have a forum where the people share, let's say, the experience, like kind of recycling different plastics. So please, at some point, if you need to get information, you have as a reference this webpage. There is a lot of them, but let's say Precious Plastic did a really nice job on gathering all this information and just giving it as a kit. So yeah, there you have loads of information to take.
Yeah, another question or something.
Yeah, just a question about the plastic bags.
Yeah.
What kind of setting do you use on your iron?
I use the setting tested until it melts.
And when it melts, it's going to stick to your iron.
Yeah, it's basically as everything when you use when you're making things, it's really about testing it out and seeing what the best. So for this one, I use my iron. I know I use the highest temperature, but if another person has a different iron, it may be a different setting. It depends really on the kind of iron you have. So you just test it because you will see. We will do some here later, so you can see how it works. But you will see as more as you go over, like for example, here was the temperature not high enough, so it didn't stick in this corner. So But then further inside, it started sticking because I was either going over more, or the temperature was higher, the white temperature, whatever, no? But it's really just testing out and seeing and getting the experience.
You can also use like baking paper.
But it's actually,
plastic, so
it's actually not an option. You have to use baking paper. But this is something we will do when some people are interested in making some of this. Because if you don't use the baking paper, it will for sure ruin your iron, like 100%.
There's like a huge network on precious plastic on different stations, collection and shredding. And other. Are there other actors in Barcelona playing with the technologies, or how are you looking forward to connect with others?
So what we're doing right now is actually working with precious plastic together to make up in general a toolkit, which is how to set up a precious plastic space within a Fab Lab or makerspace, which is more the general one. However, for precious plastic area of the north, we do have some local actors, like for example, Foss and Esferica on the other side. We collaborate with some projects. They're more like industrial sized people or like companies who recycle plastic, but also like just regular designers and makers who make products out of that. However, how we work together with them and how we can collaborate is something really much in the making process. As Mickey already said, we've been having some of the machines for a long time, but they haven't had that kind of love and dedication we should have given them. So only through the recent year now, we've given loads more attention to this topic and trying to actually be more engaged with our local community to share the knowledge, but also find actors in our neighborhood or network to make more like official collaborations and like working together on like a, I would say, strategy for, because for example, for Precious Plastic Spain, there's like a WhatsApp group in which I'm also in, and we talk about how can we set a goal, a vision for Precious Plastic Spain. Like for example, the France, they had a meeting last year with all the main spaces where they sat together and they say, okay, what is our vision? What is our vision for Precious Plastic France? And we want to try to do the same with all the Precious Plastic members in Spain to say, okay, where do we want to actually go as a country, as people who are interested in being engaged? Right. In the making progress, I would say. Anyway, I would say we should divide groups.
Yeah, as a resume, key points I will say. One is, for example, not to mix plastics. We say just as a resume, so we integrate better. Like not to mix different plastics, because like this question we heard many times. But if I want to do this and I have only this color, this plastic, can I mix these two materials? For different reasons, we cannot. But we got onto this. Like we should not mix materials to have like a pure material where after doing something we can reuse it again. Okay, and also because they have different melting points and different. So basically, it will make our work difficult also into the moment of melting them or shaping them. We will not have like a consistent material, let's say. No, so it's not nice for the practice, but not even nice also for the theory, let's say. No, so first key point I would say, like not to mix plastics. We should have this clear.
Keep all the safety stuff in place.
Yeah. And what else? Okay. So if you go to work with a material, also it's nice that you get information on the material, on like melting points, starting melting points, crystallization, etc. So we should understand a bit the material to actually set up the machines. Okay. So now we will see, we will do groups, we will decide with each of us like which material we will work with, and from this we will find information to actually work on the machine. Okay, so it's important to understand the material.
We need a group for sorting material.
Well, I think the sorting can go with the shredding. So they can sort the material they will shred. So
but then some we can sort and just,
well, we cannot undo the yeah.
Sorting and shredding.
Yeah. So sorting and shredding, one will be melting on the oven, some others will be using the sheet press, and some others will be injecting. So
go to the place where you want to be.
Yeah, well, maybe we can just like try to like separate the groups. Yes, maybe we can go in places, but I think now that we will get into the practice, maybe we take some machines out there, so we speed up with the people, and we have like different stations. So you are also allowed to move in between them if you're interested in something, but let's try to have at least like groups where we can just like get to it. Yes.
Okay. And then we meet again 15 minutes before
closing. So what time is it now? Okay, so we have 1 hour. Let's say we will have 45 minutes of practice of melting, separating, threading, etc. And then we will have a close-up session of 15 minutes just to give feedback, to just talk about what we think, what possibilities we have, what we can do better, etc. Yeah. Cool. Groups. Let's see.
Hi.
Guys, I disconnected them to hear Mikel. Guys, if you have any questions, let us know on the other side.
Okay, thanks. It was all clear.
Yeah, it was clear. Thank you.
Okay.
Can I take this out?
Yeah.
Thank you, Nana. Okay, sorry.
Okay, so
And I'm gonna take all of this off.
any preference for a station?
Daphne, if you can walk us through the steps. So first the shredding and then the pressing and etc.
Yeah, there is a shredding station. I think maybe Mikel just can explain this better. There is a melting station. I think this is the oven. The steps, you mean the order?
I mean, when they are doing it, maybe you can show us how they do it.
Okay, yeah. Now they're setting the station, so it will take 5 minutes, maybe, until they start.
Okay, no problem.
Just keep the segment until the end of the No, this weekend
So
when do you know?
as we joined selection with shredding, maybe you could take care of the shredder and you could help me with this one and I can take the injector out.
Hello again.
You have to make sure that they are
Now they are not connected because.
okay. So it's better now. It's better using the. Can you hear us?
Yeah, it's good.
Kind of good, yeah. Do you want me to take this thing or you want to use it?
No.
You want to use yours?
No, it's because hey guys, sorry. Yes.
Aquí luchando con Oye, Luciana.
We are sorry this keeps happening. It's because of the headphones. If you touch them, you take them out, it closes the Zoom. So, which one is the station?
Sorting, I think.
We are in sorting now, the first session. What?
With your teeth.
Yes.
Who has the mic? Who has the mic? Go on.
So,
Glenn, where he's he was talking about some food.
So once it's hot, it will keep hot for a while. Okay. After when we put the, well, this Arman will explain you, but when you put here you have a key to open and close the hydraulic pump. So basically, by putting it on the forward, what we will have is this close. So basically, now the shift press will come out. Okay. If we bring it to us, what it will do is release the tension and come down. Okay. Okay, we're gonna also use this. So if someone wants to go out and see like what we will do with that, in this we will use the aluminum mold. So we could like bring this machine out and then we can plug it up in there. That's cool. No, hablamos con...
okay. Any specific thing that you want to see in the lab or ask? I know this is very chaotic for you.
I wanted to ask about the molds. Can we use silicone molds or the plastics?
Silicone molds. I will ask Jess. Jess, we have a question.
No.
But then asks if we can use silicone molds for the plastic.
Silicone?
No.
Because you need high pressure for you need high pressure to form the plastic into a new mold, and the silicone will just give in.
But,
so even the wood is sometimes too soft. That's why we're using the aluminum molds now.
Yeah.
Oh, okay, thank you, thank you.
No worries.
Yeah, I think Arman.
No, creo que es más importante aparte.
It's like very starts to burn the top, then you turn off the top.
Yeah.
And you leave it at the bottom.
Yeah, I'm still trying to figure out the ovens here in Europe because we have a different system. In here, the top always burns of everything.
Yeah, it depends how you turn it on.
It's not like conventional. So we have conventional, so it's really rotating the continuous. But here, it's like top and bottom.
It depends. There are different things to rotate. So I don't know.
But this happens all the time with the baking.
So here's the thing.
So now it's almost 2.
Yeah. So we can turn off the top. Okay. Okay. So here's you can see the top and the bottom. And this is the light switch.
Oh, cool.
Usually use it on.
And the temperature switch is the top one?
Yeah, you just rotate this.
Oh, okay. And what's the bottom one?
This is the bottom temperature. This is the top.
Oh, I see. So now we just have the top one.
Yeah, I just turn off the top, so we have just the bottom.
Ah, okay.
Yeah. I think we can put.
Okay.
Let's see, what is this? Yeah, it's one. We can try with this. No, this one is open, but maybe let's see. Okay.
Yeah. We have a comment.
A comment.
Yes.
But these people know. Use what? Because sonido in
Okay, interesting.
Exactly. I was trying to.
No. We can put things, but this is a silicon mat, and we can counter. If we counter this scratch, this machine. That's why you see the black tape is because some people just drop metal parts and they broke the.
Okay.
Yeah, like Monday.
Yeah, but how was your weekend?
Drunk.
Drunk? Yeah, at someone's house?
Sounds fun.
My house.
Your house? Did you make cocktails? Did you drink wine? Did you drink beer? I want to know all the
This is drunk. There's no blue. Everything is blue.
You can do a lot of things.
Everyone doesn't have the same drink.
For what?
I was just getting drunk, but you can do lots of things when you are drunk. Stupid stuff as well.
I use that.
Now everyone can hear. Hola.
How are we?
I'm sorry. There are some discussions happening here, as you can understand.
Is this muted?
No.
Because I can.
Now.
You can
No.
manually. So basically, how to take it out. Vaseline. So we're gonna try one with Vaseline and one without. And the Vaseline helps it with. It is like it's supposed to be easier to take it off. Yeah. You want to try Vaseline? No.
Yes. Maybe this.
Yeah, when I was doing my thesis,
Wow. So
What you are using for
wait. Tell me again.
what you are put before plastic in the mold?
Vaseline. I think they put.
Okay, Vaseline. Okay.
Yeah.
Oh, me a little bit anxiety.
Okay. So, the one that doesn't have this border is with Vaseline. No, the one that doesn't have this side.
Yeah.
Okay. So we are
and the Vaseline is supposed to help it come out easier. And then we should explain to you that this here is so that because the plastic might go a little bit inside, when you take it out of the mold, you can actually lift the sides out to get it all the way out.
now we're gonna take it to the oven.
Yeah. I don't know if I explained that. Ready? Yes. Be careful, this glove usually have a hole. And then I told you I have also this thing from touching the top. Yeah, I was like, brush my teeth.
What happened?
Because I told it I was climbing this weekend, so now so, like, oh my god, I just discovered around 1 hour. 1 hour, that's it. Or this side.
It's so warm. I wanna go inside.
So maybe that's usually just or come up every 10 minutes.
We are putting the pizza in.
What time we can put it? Usually it's better to put them in the middle of those.
We're done.
Yeah. About the temperature.
Super different.
Temperature?
That's like around 200, 190, I guess, or 180.
For this plastic.
No, right now it's like this.
Okay.
For this plastic, we need 160.
Okay.
So it's a bit too much. Okay. But let's hope that it will decrease.
And like for PLA,
This is
PLA for this one.
Yeah.
What temperature? I didn't know that in Google.
This basically Madrid 101. No more Madrid.
Yeah. For me now, exactly.
I'm gonna fry some potatoes.
Yeah. I mean, just
What's the oil for? To take out the glue.
Yeah, take off the glue.
So someone could check in the internet what's the temperature of melting temperature of HTP.
I miss, what is this? I missed before when you explaining. What exactly is this?
This one.
Yeah.
Arman can explain. Can you explain this?
Oh, this is a like a temperature controller. With this, we control the temperature of the bottom plate and top plate. And there is a timer and safety button for it to just make sure that it's running safe.
Okay.
Yeah.
Thanks.
10 to 70 HTTP.
Is there any specific site that you say that?
Say precious plastic. I just want you to check.
More consistent.
Okay.
And what's the normal temperature?
120 to 180.
120 to 180.
Well, I don't know.
What?
And what's the temperature they say?
That's their research.
And it depends on the type of plastic, no?
Yeah. So now we are using HTP type 2.
And that's
So
a higher temperature.
it's a temperature, like it's between 150 and 280.
Okay.
Depends. But
And both the two need to be set, sorry, they both need to be set at the same temperature? Whatever that temperature
not necessarily.
How do you know?
They're running in like a different set of temperature control, so you can control the top layer to be less
and the bottom more because heat travels from bottom.
So actually, here it says the bottom needs to be below 37.
It says in other website, it says 266 Fahrenheit.
So the bottom should be lower because heat rises. So for example, if it should be 150, you put the bottom at like 130 and the top at 150.
Kind of, yeah.
Like this.
Yeah,
And
not
all
so
this-
much difference, but
Like 10 degrees.
yeah, 10 to 15. But in the oven, it's gonna be different because in the oven, you try to put yeah, not even like even because in
That's
the
a
oven,
convection oven.
It's convection. So
Yeah.
But this one is not a convection oven.
It's not.
Depends on the type of oven.
yeah. So if you put the same, the top always gonna burn. Should we have some? So you can see the top is burned. But
These are the secrets. I'm trying to find. This is from the oven.
yeah. So you can see the top.
So in this sense, the top and the bottom were set at the same temperature.
Yeah. So this is set in 150
And this is PPE.
HTP.
HTP.
So you need to take into account that the temperature readings are not, no, they are accurate. But what happened is, okay, imagine this. Yeah. So you have this, and this is a big amount of steel. This is aluminum plate. They have different thermal transmittance, and the temperature sensor is on the top of the plate. So the top of the plate, yes, it's at that temperature, but the surface of the plate might be slightly like 5 degrees lower, and you have the plastic. That plastic has also density, and you need to heat at the density. So that means to actually melt the plastic, you need to spend like certain amount of time to actually transmit all the heat through all the plastic. And the temperature sensor might be off a few degrees. So it happens the same way, for example, the injection. The injection is a steel pipe like this that has like 1 centimeter wall. The sensor is more or less in the middle, but the heater is on the outside. So that means the temperature from the inner core of the pipe to the outer might be off like easily 10 degrees. So it's not only about plastics and types and temperature variances, but also about where the temperature sensor is and how optimized is the sensor. So for example, plastic said that it's only for 120 degrees. Depends on the machine, might be 110 or 130 or maybe 140.
You have to take it out and press the plastic. Like during the
For example, can you like preheat the plastic and pour it instead of like tossing it in the mold?
You could preheat it, but ideally the plastic should already be dry, completely dry, because plastic also grabs humidity. So ideally before using for any application, I know especially for 3D printing because it's more sensible. What you do is you dry the plastic. One way to dry the plastic is put in a convection oven at low temperature. For example, ACPE, there is glass transition temperature. It means the moment that the material starts to become slightly fluid, but not completely fluid, it's what's called glass transition temperature. So you have the melting and the glass transition. For example, PLA is 200, but the glass is at 60. So between 60 and 200, you have a lot of offset. So to dry a material, you want to use the temperature below the glass transition. So if you want to dry, for example, PLA, you need to dry it at 40 degrees. And you need to run, depends on the amount of volume, etc., but at least for 4-hour circles to dry the material, to get all the moisture out when you finish the cleaning.
I guess now is the moment someone takes the clothes, put the sheet. No, don't use that.
So excited.
So, sliding.
And for how long?
Usually, I would say for this
30 minutes.
20 to 30. Yeah.
Super cool. And what about pressing non-plastic things?
Non-plastic.
And like biomaterials?
Yeah, you can.
Totally?
What else is your,
Oh yeah.
yeah.
I want to try doing something that I'm making with cacao waste. Because it needs a high temperature.
But how much pressure you need?
I've been trying to pressure it, like that's why I'm interested.
So here you can see now we are applying 2 bar.
Okay.
This is like a piece, it's 20 ton. 20 ton.
Oh wow.
So now I am applying close to 5.
Okay.
5 ton.
Okay.
So basically now it's a car is like sitting on this one.
Amazing.
So
This is super cool, this flat press.
yeah. So
Because actually you can use it to press other things without the heat, no? Just
yeah,
for the
without
pressure.
hitting, yeah. You don't need to turn on that.
Why are the boards a bit good? Is on
It's-
purpose?
No, this is because of the temperature. So the thing is that this board it's fixed into this grid, but when you add temperature, it's expanding a bit. That's why it's intended. You can see. But it's just like it's a technicality. So if we had like some tolerances, it's very small because it's metal just like expanding during temperature, like at one temperature. So if we had some like tolerances in the grid that allow the plate to grow inside the frame, it could prevent this happening. But it's like over engineering. Yeah. Let's learn. So this is our mode. So if you want to have like a picture, we can put figure in the side. So for now, yes, super manual. You have to basically do them all at one time. So the idea is also like in the phase of the north, they go to the area, in order to see the other clamp that gets those, you can take pictures of them. It's still very good. So it's still very good. So very good. Yeah. Yeah. These two screens is the PIDs, so they are dealing with the temperature control of the machine. So there is the first one is dealing with this preheater, so keeping this part of the tube at 210 degrees, and the last one is a bit harder or higher temperature. Is the last one. So this basically is controlling when it's heating and when not, in order to not pass. So we have to calibrate them better also because they are passing this one. But yeah, the theory is that you hold it at 220 without anything.
Because you don't want to melt too much the material on the top, but you want to have it the most melted on the bottom in order to get it through. So it's kind of like, let's say, a gradient also in temperature, kind of, yeah. Still more, 5 minutes. That system, well, if you actually have it thought and you have the next question we should go to ourselves is also how much volume of plastic we can accept in the tube, or if we can inject it twice, you know. So these are questions that we should think about, solve, and calculate, because we have to understand how much plastic we should have there in order to know how big the mold can be.
I have a question.
Yeah.
If you experiment with 3D printed molds.
With 3D printed molds. The problem with 3D printed molds is that you are 3D printing it. So basically the temperature that we at least could get into the lab into melting plastics, or you get like a super high temperature plastic with the one you do the mold, and then you try with a low temperature melting plastic which you can inject into the mold. But the problem is that at some point your 3D printed mold will melt also. So when you are applying temperature, the best way to do it is not by 3D printing a mold. We tried with wood, we tried with different materials, never with a super good result. We could take something, basically if they are like basic geometries, but with a 3D printed mold, even like if it's like a plastic that doesn't have a lot of difference with the melting point of the material that you're going to inject, it doesn't make too much sense, because your mold will also like get the shape, like lose your shape, etc. So we tried, but without success. How do we know? We have one hole for entering the material, and we have 2 holes in the end of the mold in order to let the material out and let the air through. So basically, when we will inject, if we see plastic coming out from these 2 small holes, then we know that the mold is full. We know we have to change things a bit, but for now we are doing like this. I think soon we will be kind of ready to take out the mold, inject a little bit. So you could be pressing this. Okay. So what we'll do is you press a little bit, and when we see liquid coming out, we will put the mold and then inject everything. Okay. Maybe you or whoever wants can help me to take out the mold. We put the mold, and then someone has to dive deep and then stop. You have? You do? Why did you have to take it out? Because the corner here, between this heater and the mold, as this was cold, it creates kind of like a tap. So it's not melted too much in material there. So what we want is to take this not melted material and then have the super melted one to like the liquid one. That's why I'm also putting there to see, but I will not try it, because if we try and we just get like a tiny between, we have to mold the mold and everything. So I will prefer to just have it like when we see it's liquid, we inject it, because if not,
it will block the entry, so we have to mold them, like open the mold, and
That part is already a
this part is 200, but maybe when we put the material, there is material there that wasn't at 200, like some material. That's why I'm putting the gun there too. But for my experience trying, it never happened that in the end it's good melted. So it always blocks the mold. So I take it out and then we do it. But in these things, we have to do lots more tests. So we need people also like doing. I think we're good. Maybe you can hold the gun, or for now we can switch it off, but have it on for if we need it. Okay. So who's coming this side? I go there. Or you do this. Okay, so you can come this side. Okay. So take out the mold. Okay. You press a bit, press a little bit, until we see the material coming out. It will look like a spatula. Okay, wait. Okay, press a bit more. Press a bit more. So you see this is not melted, no? Press a bit more, a bit more, a bit more, a bit more. Okay, there. Está quemado, ¿eh? Pon el monte. Perdona, Roget, use. Más. Press. We should have. Let's come on. No, because the plastic is black. This means that we overheat it. Yes. I said we will overheat it.
Excuse me, all the ones who are close to the machine, please.
Thank you, Jess.
Safety goggles. Because it's hot plastic. Yeah, I mean, it's really hot. If anyone is close, right there.
You can well, let it like this. It's fine. So you see the material is super black. It means that we overheated the material, which I said this will happen.
I burned that.
Before.
Right.
So we lost the color. You see, there is also kind of like a problem. Okay, that the outside is kind of like super melted and the inside is not even melted. Yes, the outside is burnt. You can see it's black, and you can see on the that the pellets inside they are not even melted. Like this is still like this. See? So this is also another problem. We should get the more homogeneous material. Not distributed well. We maybe will have to stay with the material inside there for longer time but lower temperature. So this kind of thing we still have to yeah.
Do you know where that plastic comes from? Not from that. It comes from
which plastic?
No, it's
that one on the side.
No, yes, because we take out the beginning. So this was the beginning. So this started being melted, and then we put them out. So this material came before to inject. We took out them all, we injected this material that is in the floor, then we put them on. Okay. So now this is super hot. So I think we could put it in water outside or something. Yeah, and then we can open it. So we pull it down, and then we can open and we can see what we take out from it.
Now it's hot like.
Yeah, now it's hot. Yeah, take it outside, put some water so we cool it down a bit, and then we can open it. Next time everybody will have gloves and we'll just take
Does the rate of wind influence the property?
Yeah, if we pull it down quick, it might crack a bit, but it's just to see how it comes out. I want to say this might influence the property of the material because now we will cool down quickly. So basically the material can be that when we change the temperature so quick, it might warp, it might move a bit. So it might kind of like make tiny cracks onto the mold. It's just a way that we can mold it now and see what we have. But theoretically, it will be better to just let it cool down in a slow curve of temperature, let's say, in order to have like a more stable material. ¿Vos crema? Pues sí, crema, ¿eh? Sí, ahora todo. Mira, mira.
This is the worst. It's a bit like por aquí. Cuando lo metes en agua, no, allá.
Sí.
You want to open your mouth? But the thing is that they're not small enough to pass.
They're not small and yeah.
No, don't worry.
I just had a deja vu, so please hold this.
Why not at the moment?
What's this thing LP, HP, HP.
Sí. Estoy en el rango, pero maybe I will.
Take out this, so it's input, because we have to kind of break this with the hammer, no? Yeah, so we'll put the spatula and the.
Cold.
oven. Like, if you can.
Yeah, I wanted to go in the oven.
That's why I was holding the mold because it was warm flowers.
Creo que es el chico francés también. No, esa... Mira, creo que es el de la máscara azul que está en la... Creo, pero me podría estar equivocando. This is like this, it will break it favorite. This still also has to be optimized. And now to take this is difficult. Again, I created one with 1 degree. I can show you what happened.
Eso es lo que ha pasado cuando te has escupido.
Sí, that's
Y es donde se ha ido el material que debía estar ahí.
Yo quedaba ahí. Yeah,
Sí.
So look, this one, you see it's destroyed because this was too thin. Okay, when I injected the material in here, this kind of moved all this piece to one side. Okay, and then I had this. Okay, so it's pretty bad. So basically what I did is to remake the mold, but at this time I didn't lose time into doing 1 angle degree that this have. So basically this, anyway you don't see too much, this have like towards this way, have an angle. So basically when you mold it, it will mold easier. But basically this mold broken, it's broken, or it broke, or it break. So I did this one. But yes, in this I didn't lose the time, let's say in machining to do the 1 angle degree. So that's why we have the problem on molding. Okay, but theoretically we should put an angle, which is specified for mold making, like how much thicker your mold is, how much angle you need. You know? So basically this is a 10mm acrylic, we need 1 angle, 1 degree of angle, but we had it here, but then like to rush to see if the mold was actually working, we did that one, but this don't have the 1 angle. How do you take this out? We could do like, no, we could like put something underneath, like some for wood blocks or something, and we could try to hit it out. Sí, pero el problema es que tampoco no sé si van a ser exactamente iguales, y justamente lo que va a picar es el material que tú quieres sacar. Lo guay sería que fuera en este, pero este está deformado, entonces no sabemos dónde vamos a picar. Yeah, dude.
If you put this form underneath and just bang this really hard, you're not going to break it.
Yeah, it might be. This also because we cool down with water, so we kind of like made the material more fragile. Exactly. And also because we are forcing it to take it out. This is a 3D printed one?
Yes.
And which material is using?
Can you tell us the material you're using?
High temperature resin.
What?
High temperature resin in Formlabs 3D printer.
So it's resin from the Formlabs.
Yeah.
Okay, and it doesn't heating. It doesn't have any change on the shape, right?
You cannot use it same way like metal one, but you can use it for 10 or 20 pieces. So it will degrade quality after some time.
We will try that because we have also some resin printers here. We will try that.
Yeah, high temperature resin is, and we even try with the FDM with the nylon, and it's also so when we have a workshops, it's much easier to elaborate with the kids and young people how to make mold when they actually made one with a 3D printer.
Cool. I will give you the feedback when if we try. We will try with the resin ones first, and we will give you the feedback.
Yeah,
Thank
super.
You. I appreciate your insights.
Super.
Sorry. To gather the people. Guys, yes, everyone. Thank you all for coming, and I hope you all had fun and had some ideas, or maybe also not. At least had some first exploration with some material stuff and some things and ways of how to use it. I would do a quick wrap up about this, and I would say, if it's possible, if we go one round, either like one sentence or one word or one key takeaway, really quick about everyone. That would be really cool. We have 10 minutes time for this, so it has to be really, really quick in the end. If anyone wants to start, one key word or takeaway.
Idea.
Upcycling this.
I was going to say that.
It's not fully automatic, and you have to do something by hand.
Yes.
Okay, no?
They're not participating, they're just looking.
It's also really beautiful, the outcome. Like visually, it's something that's really beautiful.
Sorry, everyone has to do it. One key takeaway or one word you want to say about the workshop today? Useful.
Potential and possibilities.
Can you also make it like this stuff?
I would say be aware of safety.
Sponge testing it out.
It requires a lot of patience.
Long way to go, but super interesting.
We were wondering with Jasmine how much energy are we using to do this whole process in business. It's a long way to go.
Yeah, for sure.
No pressure.
Enjoying the process.
The importance of the right temperature.
Yeah. Good point as well.
Reconciling with material.
It has a great potential. It can be in many forms, like CNC, even after this process. But we found that it's it fails sometimes and it breaks or something because of the air bubble. So it needs some more research that can be improved.
I would say iterations.
Anyone from there?
Anyone from the other side? Also, a lot of opportunities.
Yeah.
And anyone else? Speak now.
Or shut forever.
Okay.
In any case, you can all see there's a lot of progress which we have to do. We have to still iterate, we have to test things and research. There's still a lot of ongoing projects and process with us. Any case, I'm super happy that we all came today and had this exploration. If you're more, you know, you can go to Wiki and come to me and see how we can make this work for you guys. But yeah, that's general idea. So have a great day, have a great break now, and please help to clean up really quickly before we leave. Yeah. Thank you guys.
Bye. Bye, guys.
Bye bye, Kira.
Bye.
Thank you.
Thank you. Bye.